Hey kiddos, I hope you're having a great day. Today we are going to move on to a new learning target. So our new learning target today is I will learn how to rationalize a radical expression. So I know that sounds kind of scary, but I promise it's not too bad. A radical expression, that is just an expression that has a radical in it. So it has square roots, cubed roots, things like that. And to rationalize is going to be one of our vocabulary words. It's the process we use to get radicals out of the denominator of a fraction. So we are going to put that in our notes for today. Make sure you are following along, taking good notes, pausing to rewind something or get stuff copied down, all that jazz. So today this is our rationalizing. Rationalizing expressions. Okay, and to rationalize, the definition is the process to eliminate a radical from the denominator of a fraction. So this is a skill that often comes up on the ACT a lot. That's another place that you'll see it later down the line. So it's a really good skill to learn for that purpose. So kind of like when we deal with, we've dealt with negative exponents a little bit before. There's just kind of some rules in math that like you just don't do. They're just not like the proper way to do things. So like negative exponents, you're not supposed to have negative exponents. So we always bring those to the top or to the bottom to get rid of those. The same thing with rationalizing. We do rationalizing because it's not proper to put a square root in the denominator of a fraction. That's just not how mathematicians work or how they don't like to organize things. So there's this process called rationalization in order to try and overcome that problem. So for instance, if we have an example, we have the square root of x over the square root of 2. So we have a radical in the bottom. We do not want that. So the way that we get rid of radicals in the bottom is we multiply by the bottom and the top and the bottom of a fraction. So essentially we're just multiplying this fraction by a fancy form of 1. Because radical 2 divided by radical 2, that's still going to give you the number of 1. Kind of like 5 divided by 5 is 1 as well. So when you multiply these together, what's going to happen is radical 2 times radical 2, it is going to actually end up as 2. And the way we can check that is in our calculator. Essentially, the 2 square roots are going to cancel out, which is really neat. And you are just left with 2. So when you're multiplying 2 square roots, if they have the same radicand, so if the thing inside the radical is the same, when you multiply the square roots, you're just left with what was inside. And then going back to what we did the other day, when we multiply radicals that are different, you can just multiply them together. So that's going to give us radical 2x. So that's not too bad. So your process is going to be to multiply your original fraction by the denominator on both the top and the bottom. This is a process called rationalization. So along those same lines, if we have example 2, we have radical 7 over radical 3. Radical 3 is my denominator, so that's how I'm going to make my new fraction to multiply by, just a fancy form of 1. And that is going to give us radical 3 times radical 3 is going to leave me with 3. Radical 21 times radical 21, radical 7 times radical 3, got ahead of myself, is going to give me radical 21. And when you're doing these, you always have to check to see if you can simplify any further. So 21, that's going to give me 3 and 7, and I can't simplify those down anymore. So that can stay, radical 21 over 3. So as always, I do kind of get a little bit more advanced. So we could also have something that looks like this. Radical 5 over radical 8x. So 8x is in my denominator, so that's what I'm going to multiply by, radical 8x, radical 8x. So this is going to give me radical 8x times radical 8x is going to leave me with 8x. Then we can multiply our radicals up top. 5 times 8x is going to give me radical of 40x. But then I have to see if I can simplify this down. So we're going to start with our 40. That's going to give us 8 and 5, 4 and 2, 2 and 2. I have a pair, so that's going to give me 2 radical. 2 times 5 is 10. So that's going to give me 2 radical 10. And then my x. Can I divide x by 2? No, I cannot. And it can, if I was to make my factor trees, I just have an x and an x, no pairs, so it's going to stay in the radical. So your answer for this one is, it becomes 2 radical 10x over 8x. And then I'm still not done. I can still simplify this one step further. I can simplify my 2 and my 8. So 2 divided by 8 is going to give me 1 over 4. So I don't really need my 1 there. Oh, bring down my x, and I'm going to have radical 10x. The important thing to note here is you cannot divide these x's. This one is in the radical and this one is not, so you cannot divide like that. Those just stay the same. Okay. All right, so we'll also be given some stuff that looks like this. We'll have 2n over radical 16 n to the 5th. So again, first thing we're going to have to do is multiply by the denominator. 16 into the 5th, 16 into the 5th. All right, so that is going to equal 16 into the 5th on the bottom. 2, and that's not in a radical, so it's just going to be 2n times radical 16 into the 5th. And then I'm going to have to simplify inside the radical first, and then I'm going to worry about what's on the outside. So radical 16 into the 5th. We can recognize that 16 is a perfect square. So the square root of 16 is going to give me 4. So that's good. And then I have to do the square root of n to the 5th. So into the 5th, I'm going to have 1, 2, 3, 4, 5 n's. Circling my pairs. So I'm going to have n squared and then n left on the inside. So now if I rewrite that, I have 2n times n squared on the outside times 4 with n in the radical all over 16 n to the 5th. Oop, y'all can't see that. And I can simplify that even further. So I'm running out of room here. We'll do it over here. So 2n times n squared is 2n to the 3rd times 4. It's going to give me 8n to the 3rd radical n over 16n to the 5th. Okay, and then I'm ready to simplify for my final answer. 18 divided by 16, that's going to give me 1/2. So it's going to be a 2 on the bottom, a 1 up here. Start whichever one is bigger is where you're going to start. So 5 minus 3 is going to give me 2. Or you can think about it as 2 minus 5 is negative 2. Can't have negative exponents, have to bring it to the bottom. And radical n. So essentially we don't need that. So it's going to be radical n over 2n squared. And that would be our answer for that one. We will do one more example. All right, let's say that we have 5k squared over 3k to the 8. Same thing, going to multiply by 3k 8 3k8, and that's going to give us, multiply radicals, they cancel. We're going to be left with 3k to the 8th. These we cannot combine, so we just multiply them like so. And then we have to simplify inside of our radical. So 3, that's a prime number. We can't simplify that down any further. But we can do k to the 8th. 8 is divisible by 2. So that is going to give me 5k times 8 divisible by 2 is going to give me k to the 4th on the outside. And then I'm going to have radical 3 on the inside over 3k8 on the bottom. Combine like terms, that's going to give me 5k to the 5th because 1 plus 4 is 5. Radical 3 over 3k to the 8th. I can't simplify my whole numbers anymore, but I can simplify my exponents. So that's going to give me 5 over 3. And then you can either start at the top. 5 minus 8 is going to give me negative 3, so it goes in the bottom. Or 8 minus 5 is going to give me 3 as well. So k to the 3rd in the bottom, and then my radical 3 stays up top. So this would be your answer to that one. Oh, I'm sorry. This is supposed to be a squared. I lost that. So that would make this 6, and that would make this a squared. My apologies on that. I just realized that. See, it's very easy to make mistakes in math. I totally get it. Very hard to lose things when you're copying. So your answer is 5 radical 3 over 3k squared. So that's kind of a, it's a little bit of a lengthy process, but I don't think it's too hard. We're just kind of adding on to skills that we already have, that we've learned in the past few weeks. So in Delta Math, let me get that pulled up for you all. You're going to have an assignment that says rationalize a radical expression. And you'll have 2 sections. This will say rationalize a monomial. Yeah, mononomial. That's an odd word. It just means one term, denominators. And they'll be in this form. Or you'll have some that, let's see, fractional. Some of them are already going to be given in simplest form, so you're just going to have to recognize that. Some of them you'll have to solve and then simplify, only one of them. And some of them, the radical and the fraction require simplification. So we'll do some of those, and then we'll also have some with variables. So we'll be doing the ones that like we just did in our last couple examples. We'll have a couple of these to do. As always, not sure which group of you is watching this video today, but these are here for you to watch and learn. Even if you're someone that got the instruction with me in person, maybe you need to hear it again. That's why the videos are posted for you, as well as make sure you're bringing your questions to class, you're staying on top of stuff, and reach out if you're struggling. Alrighty, hope you all have a great day. I'll see you when I see you.